Hi guys, this is part 2 of the memory game with Python and Pygame video series, where I show you how to build a great looking memory game using Python. In this video, we're going to cover how to make the game board, how to randomize the game box positions and sprites, how to draw a sprite onto the game board, how to create the box covers and reveal the sprites inside them, how to create animations, and finally how to implement the endgame logic. So we're going to be building a series of functions which have been already coded out for you. I'm not going to implement everyone line by line, but you can find all this function code in the description box below so that you guys can easily use them. I will be giving a explanation of what each function does so you guys have a better idea of how the application as a whole functions. First, we're going to start with the generate revealed boxes data function. This function takes in a Boolean value called a val, and it outputs a revealed boxes array containing a Boolean value times the height of the board. So this is a function that outputs a array containing Boolean values. For the starting iteration or the event of the game, uh, this val variable is given a false value so that each box is given false value, so that means to cover up each box, and a true value would mean to reveal the box, thereby showing the sprite that's under it. Next, we have the get randomized board function. This function gets a list of all the possible shapes in every possible color onto an array called icons. Then it randomly shuffles that icons array, and after that it makes two copies of each element in the icons array, which is then shuffled again to ensure that the no duplicate or um, sprites are standing beside each other so that it's as random as possible, making it harder for the user to guess the position of the matching sprites. Then we have a loop and a double for loop, appending each icon contained in the icons array into the board 2D array. This is done using the column array. And then finally, once the board array is populated with all the required icons, it is then transposed to ensure further randomization of the box positions and then returned as a 2D array. Next, we have the split into groups of function. And what it does is it splits the box, the game board, into a group of boxes. So the group size is the parameter from which it decides to split the box, the game board into. So let's say you pass in a 2D array representing the game board containing a 2D array list of boxes. If we pass in a group size, and let's say the list is 4 by 4, so 16 boxes in all, and let's say we have a group size of 4, so then this would result in 4 different box groups. So what it does is it divides that list of 16 boxes into groups of 4 by 4 box groups and then returns the result as a array. Next, we have the left top chords box function taking in a box x parameter along with a box y parameter. The purpose of this function is to convert box coordinates to pixel coordinates. So box coordinates would be any coordinate that's part of the board, with the box y coordinate being the top most box coordinate. So what it does is it gets the coordinates of the box, and box x and box y are pixel values. So it transforms pixel values into box coordinates using the box grid system. By default, for level 1, the box array is 4 by 3, so it's 4 columns and 3 rows. So whatever pixel coordinates the user clicks on, that is transformed into a box coordinate, which is useful when in order to find out which box the user clicks when the game is in progress. Similarly, we have the get box at pixel uh, function. It takes in a uh, value of x and y, which is pixel values, and it goes through the boxes in the box array, and it checks using the collide point uh, method whether a click registered as a click on the box or not, and if so, for example, if we click on this box right here, if we whether it's a closed box or not, and whether or not to reveal it. So that returns the box X and Y coordinates of that specific box. If we click it here, it won't return anything because it knows that this is not a box. Next, we have the draw icon function. This function is mainly used to draw sprites that are displayed on the game board. It takes a shape, color, box X, box Y parameters, and using that information, the appropriate shape with the appropriate color is created by calling the appropriate draw sprite function to create and draw that sprite onto the main game board. The get shape and color function is used to identify the shape and color for a given box position. As an example, let's say the user clicks on the first row's and second column's box, and these coordinates are then passed to this function, which returns what the shape and color of that box is. So, for example, first row, second columns box. If we click that, this box information is then passed to this function, and it returns what the shape and color of that tile is. Next, we have the draw box covers function, and this does is it takes a list of boxes and a number value for coverage. For example, this function can be used in the starting seed of the game where all the boxes are revealed for 1 second before being covered. What happens is that this function is repeatedly called, and with each call, all the boxes are given a different coverage amount, starting from a positive value and eventually getting to a zero value and a negative value, where the positive value is when the box is um, fully covered, if not partially covered. So like there, and now this box has a negative value, and then it goes to a zero value at which it is revealed. And then once it starts going back to a positive value, it is then covered back up. So this, so you can think of this function as a frame drawing function for the board, basically drawing each frame in that sequence of animations where the box is covered and then revealed. So that's what this does. Then we have the reveal boxes animation function, and it takes in the main game board and a list of boxes to reveal as the parameters. It goes through a list for the coverage of the box tiles, and in order to do the box reveal animation, it repeatedly calls the draw box covers function, sending that function the boxes that are to be revealed via the boxes to reveal variable, and a list of all the coverage values indicating to what extent the boxes should be revealed or covered. As you can see here, these are the coverage values that are being printed here. So a positive coverage value indicates the box should be fully or partially covered. A negative or zero value indicates the box should be revealed. thereby displaying the sprite that's underneath it. Okay. Next, we have the cover boxes animations function, and basically this function is the inverse of reveal boxes. Note that we start from a positive number and then we go towards a negative number in reveal boxes animation, which is then uh, undoed or reversed using the cover boxes animations function where it starts from a zero value and it moves towards a positive value, so thereby covering the box. Okay. Next, we have the draw board function taking in the game board and a 2D array filled with Boolean values representing each box, where false means the box should be covered and true means that the box should be revealed to display the sprite that's underneath that box. This is done by the revealed 2D array containing a 2D list of all Boolean values representing the corresponding box. And if the Boolean value is false, we know that it should be covered. The corresponding box should be covered. And if it's true, then we get the shape and color of that box to get the sprite. And then we draw that sprite using the draw icon function. Next, we have the draw highlight box function. This function is mainly used in the highlighting of boxes. As you can see here on the hover event, all boxes are being highlighted by a blue background. And this is a useful indicator for the user because it makes the application more responsive. So that's what draw highlight box does. Next, we have start game animation function taking in a 2D array of box coordinates. First, we're going to generate the list of covered boxes. Then we go through each box and shuffle them. Um, and we generate the boxes array and we shuffle those the elements in those boxes. Then we split the box um, board array into groups of box groups. In this case, since on startup, we can see that all the boxes are revealed as shown here. Watch closely as all the boxes are revealed for 1 second. We're passing in all the boxes as a single group so that the user has a better, easier time to memorize the positions of each box and the sprite contained inside them. So that's what the box groups does. It holds all the boxes in the array. Then we call the draw board function to draw the board along with the covered boxes list. And for box groups, we first call the reveal boxes animations function. This function reveals the boxes, uh, basically undo the cover and then display the sprite underneath them. And then you pause for 1 second and then we cover it back up using the cover boxes animation method. So that's what start game animation does. It fires up all the animation logic on game startup. Then we have the game one animation function, uh, taking in the board and as an array, as a 2D array. This function is called by the main loop when it has detected that the game has a winning condition, being that each box is matched with its corresponding matching box in shape and color. It then uses a for loop to create an end game animation using the color 1 and color 2 variables to swap colors and then fill the game display window with these colors. It then draws the new game board, which is going to be the level higher than the current level. So in this case, if we were to complete this game, it would go to level 2, and then it would display update, refreshing the Pygame window, and then wait 300 milliseconds before exiting the function. And then we have the has one function, basically called every time a matching pair of boxes has been found. So if a matching pair of tiles has been found, this function is called and it increments the game score by 10. Uh, it also goes through the revealed boxes array to check if the game is currently in a winning condition as a result of those clicks. So if all the boxes were revealed and matched appropriately, the return true condition is met, and the main game loop knows that the level up condition has been met, and thereby would increment to level 2. If not, then false is returned, and the game knows that to stay in this current level as there's further tiles that have to be matched by the user. So that's it for this video. I hope that makes sense to you now. Please feel free to go to the description and get all the source code. And please make sure to understand what I've done here so that you have a better idea of what this application does and so that you can learn more about this application and all the programming principles that went into it. In the next video, I'm going to be covering the main method, which is displayed here, the making of the main method along with some ancillary functions and classes, like the button class that you see here. These classes have to be, these functions have to be made. And yeah, so that's what I'll cover in this third video of this series. Thanks so much for watching, and please make sure to like and subscribe. If you have any comments or criticisms, please leave them in the comments section below. And have a great day, guys. Bye.